All right. What do we have here? A geometric problem. It's about circles and angles. In the diagram below, given BA, this is BA, chord is parallel to CD, secant CD, or another chord CE. And DA, DA is tangent to the circle at A. DA is tangent to the circle at this point over here. Or this tangent to the circle at this point. Let me just change the okay. Is tangent to this circle at point A. Um, prove that angle 1, this angle 1 over here, should be equal to angle 2 over there. That's great. Let's see first what is each one of these angles equals to. Let's take angle 2 first. Measure of angle 2 is equal. Angle 2 is an exterior angle located between a tangent and secant. Okay? This angle should be equal to this arc, measure of this arc AC, minus measure of the arc AE, divided by 2. So it is equal to half measure of arc AC, and let's say arc ABC, right? Minus the measure of the arc AE, measure of arc AE. Okay, this is first step. And the reason of that is, exterior angle between or formed between a tangent and a secant. Tangent and a secant. That's great. This is measure of angle 2. Let's say measure of angle 1 equals to what? Measure of angle 1 is equal, this measure is inscribed angle, right? And its inscribed angle faces or intercepts the arc AB. So it's equal half the measure of the arc, AB. That's great. This is the reason for this is inscribed angle intercepted inscribed angle, or definition of inscribed angle, intercepted an arc, equal half of its measure Also, that's great. All right, what we need to prove that this angle 1 is equal to this angle 2. So first step is the easier way to do such problems. First step, I did find what is the measure of angle 2. Then I did find what is the measure of angle 1. Now I have to compare these measures and to see if they are equal or not. Let's go back to measure of angle 2. Measure of angle 2, can we simplify it? Let's go to measure of arc ABC. Yes, we can say it's measure of arc AB plus measure of arc BC, right? This is measure of ABC. I split this measure into two parts, and minus of measure of arc AE, I left it. And this because of arc addition postulate, right? That's great. I need to just have half measure of arc AB, so this angle measure of angle 2 will be equal to half measure of arc AB, and then it will be equal, in this case, to measure of angle 1. How to do that? To do that, I should cancel these two measures, right? And to have them cancel, measure of arc BC should be equal to measure of arc AE. Look at that. Is measure of arc BC equal measure of arc AE. Correct. These two arcs are located between this chord and this chord. What about these chords? Remember, we did not use yet, that these two chords are parallel. And if they are parallel, then the property says the measure of the arcs between them are equal. And why is that also, I would like to say. This angle here, right? Is it equal to this angle? This angle is equal to this angle, right? Why? Because those angles are alternate interior angles of parallel straight lines. This angle is angle A, which is BAC, is inscribed angle that faces the arc BC. And this angle here, which is the ACE, is inscribed angle that faces the arc AE. This angle faces arc BC, so is equal to half of its measure, half measure of arc BC. And this is half measure of arc AE. So since these two angles are equal, then their answers are equal. So half measure of arc BC is equal to half measure of arc AE, right? This means the measure of arc BC equal to the measure of arc AE. Since these two arcs are equal, so we can do what? We can cancel them. They have the same measure. Then what left for angle 2? Measure of angle 2 will be equal to half the measure of arc AB. And what is half the measure of arc AB? It's angle 1, so it's equal to measure of angle 1. And I did prove this. Why angle measure of angle? Since measure of angle 2 is equal to measure of angle 1, then angle 1 is congruent to angle 2. All right? So that's it. That's it for this. For sure, we have to put the reasons. Here we subtract, right? And here we did what? We just did substitution between these two measures, right? And then we discovered that these two angles, since they have same measure, then they are congruent.